Welcome dear students, this is a short video in which we are going to discuss a small trick to find the maximum possible number of geometric isomers of an organic molecule. We have already discussed geometric isomerism in detail and we have studied that to show the geometric isomerism, a molecule must have restricted rotation around any two carbon atoms and those two carbon atoms must have two different groups attached to them. So if the two conditions of the geometric isomerism are fulfilled, then there is a simple trick to calculate the maximum possible number of geometric isomer of that molecule. In the case a molecule is given, first of all you will observe the ends of the molecule. If the ends of a molecule are different, just like in this molecule, both the ends are different. At one end there is methyl group, at the other end there is chlorine atom. So if the ends are different, then the formula to calculate the maximum possible number of geometric isomer, that is 2 raised to power n. And here n is actually the number of pi bonds or the number of double bonds present in that organic compound. In this case, you can see that this organic compound, it has two double bonds, so n will be equal to 2, and according to this formula, the maximum possible number of geometric isomers, that will be 2 raised to power 2 and it will be equal to 4. Now, my dear students, if there is an organic molecule in which both ends are same, just like in these two examples, you can see that in this compound both ends they have chloro group, and in this example both ends they have methyl group. If the ends are same, then you will have to see whether there are even number of double bonds or the odd number of the double bonds, because the formula will be different for them. If the number of double bonds are even number, then number of geometric isomers is equal to 2 raised to power n minus 1 plus 2 raised to power n divided by 2 minus 1. So this one will be the formula to calculate the maximum number of possible geometric isomers. Let us find in this molecule what should be the value of n. 1, 2, 3 and 4. It has 4 double bonds, so n will be equal to 4. Now the number of possible geometric isomers, that should be equal to 2 raised to power 4 minus 1 plus 2 raised to power 4 divided by 2 minus 1. 2 raised to power 4 minus 1, that will be 2 cube, plus 2 raised to power 4 divided by 2, that will be 2, and minus 1, so that will be 2 raised to power 1. And the cube of 2, that is 8, and 2 raised to power 1, it is equal to 2. So the maximum number of possible geometric isomers of this molecule, that can be 10. In case when there is odd number of the double bonds, then the number of geometric isomers, that is equal to 2 raised to power n minus 1 plus 2 raised to power n plus 1 divided by 2 minus 1. Now in this example, the value of n is equal to 1, 2 and 3. So it has 3 double bonds. According to formula, number of geometric isomers is equal to 2 raised to power 3 minus 1 plus 2 raised to power 3 plus 1 divided by 2 minus 1. It should be equal to 2 raised to power 3 minus 1, that will be 2 raised to power 2. 3 plus 1 is 4 divided by 2, that will be equal to 2. So answer of this complete, it will be equal to 2. Minus 1, that will be 2 raised to power 1. The square of 2 is equal to 4 and 2 raised to power 1 is equal to 2. So it can have maximum 6 geometric isomers. So in this way, if a molecule is given and all the conditions of the geometric isomerism are fulfilled, then you will see the ends, if they are different, apply this formula, and if the ends are same, then calculate the number of double bonds, whether they are even or odd. In case of even number, apply this formula. In case of odd number, apply this formula. Just you are required to put the value of n, which will be the number of the double bonds, and you will be able to find the maximum possible geometric isomer of any organic molecule.